Hello class, welcome to our online lecture in Statistics and Probability. In this series of lecture, we're going to learn concepts related to estimation of parameters. Specifically, we're going to learn how to differentiate parameters and statistics, to define statistical inference, understand the concept of estimation, differentiate point from interval estimate, find the point estimates of population means, understand confidence level and confidence interval, find the corresponding confidence coefficients for a specific confidence level, and understand the concept of margin of error. So to begin with, let us talk about some of the related concepts in estimation of parameters. So first, we need to learn how to differentiate parameters from statistics. So when we say parameters, it is a number describing the whole population. So these are the values that we use in order to describe the characteristic of a population. So parameters are derived from the entire population. So for example, we have the population mean, the population variance, and the population standard deviation. So if it is possible for us to survey or to get the data from all of the elements composing the entire population, then we can solve for the parameters of the population. But we know that in real life, it is difficult, so it is rare for us to survey the entire population because the population tends to become very large most of the time. So that's why we perform sampling. So when we describe a population based from a number coming from a sample, so coming from a sample data, for example, the sample mean, sample variance, sample standard deviation. So these values now is what we call statistics. So we use statistics in order to estimate the parameter of population of interest. So therefore, the sample mean is the um, estimate of the population mean. So sample mean is the estimate of the population mean. Sample variance is the estimate of population variance. Sample standard deviation is the estimate of population standard deviation, and the same applies to other measurements. So any number that describes a sample is an estimate of its equivalent values that describes a population. So we use statistics in order to estimate our parameter of population. Another important concept is statistical inference. So statistical inference is based on the numbers that we derive from our sample. So when we use our statistics in order to describe the characteristics or to generalize the characteristics of the population, then we are doing statistical inferencing. So statistical inference is a process of drawing inferences about the population based on the information contained in a sample which is taken from our population. So statistical inference has two main we can do statistical inferencing in two ways. So we can estimate the parameters or we can perform hypothesis testing. Estimation of parameters is a procedure by which we obtain an estimate of true but unknown value of population parameter by using the sample observation. So we are estimating the population parameter using sample observations. So for example, so we may estimate the mean and the variance of population by solving for the mean and the variance of the sample. On the other hand, hypothesis testing is defined as a procedure that enables us to decide based on information obtained by sampling whether to accept or reject any specified statement of hypothesis. So regarding the value of the parameter in a statistical problem. So therefore, this is a procedure that helps us decide whether to accept or reject our hypothesis, our null hypothesis. But we are interested in this lesson on how to estimate parameters. So let's go back to estimation of parameters. Again, so if we define defining estimation of parameters, sabi natin, this is a procedure by which we obtain an estimate of the true but unknown value of population using the sample observations. So first, for estimation of parameters, we need to define estimate and estimators. When we say estimate, these are the numerical value of the unknown parameter obtained by applying an estimator to a sample size n taken from a population. So if we have a sample size and we were able to gather data from our sample size, then we can apply an estimator in order to get our estimate. So estimate is a numerical value. On the other hand, an estimator is a rule or formula used to obtain the value of an estimate. So these are the formulas we use in order to solve for the value of our estimate. So for example, in the problem, Susan, a TLE teacher, looked at the average time in minutes it takes a random sample of customers to be served in a restaurant. So from 40 customers, the following information was obtained. So this is our sample. So this is our data gathered from a sample, n is equal to 40. So from this gathered data, we can solve for the mean of this sample. For example, if we solve for the mean, so meaning the average of all of these values that we get from our sample, so the average, the mean of the sample will be 32.5 minutes. So this value, the mean of the sample, is a value that estimate the population mean. Since it becomes difficult for us to gather all of the possible values from all of the possible population, all of the possible elements comprising the population, then we can get a sample, and based from our sample, we can solve for the sample mean. So this sample mean is called an estimate of the population mean. So sample mean is an estimate of the population mean, sample variance is an estimate of the population variance, and sample standard deviation is an estimate of the population standard deviation. And the same applies to others. For example, median, the median of a sample is the estimate of the median of a population. The mode of a sample is an estimate of the mode of a population. So any measure that describes the sample is an estimate of the measures that describe the population, corresponding measures. So there are two ways of estimation. So first, we can perform point estimation. Second is interval estimation. So when we say point estimation, it is using a single value that estimates the population parameter. So for example, if we have our sample mean, so mean of 4.5, then this is a single value that tends to characterize our population, estimates the characteristics of a population. On the other hand, so we have here the interval estimation. So instead of using a single value, we have here a range of values within which we assume that the true value of parameter is believed to be found. So for example, we can say that the true population mean is from the mean For example, 2 until 5. So meaning the true population mean can be found within this interval of estimates. So later, we will learn on how to perform point estimation and interval estimation and the difference between